Hello student, in the last lecture we were studying this slide. Okay, so what happens here actually in the multiple development? So for the first, this is developed for 2 or 3 times. Okay, you can say for 2 times. So first time the chromatogram is developed in this direction. For the second time it is developed in this direction. Okay, hence the name is multiple development. Okay, once these components get separated, okay, once this component gets separated, now in the next, now for the next time what I'm going to do, I'm just rotating this slide and keeping in other direction. Okay, or I'm making it horizontal. This is vertical. Next time I will keep it, I will make it horizontal and keep in the mobile phase. Over there these components will again run in this direction, in this direction. Okay, if these spots which are visible on the screen, if they contain more than one component, they will also get separated. They will also get separated. And for the multiple development, either you may use the same solvent or you can use other solvent also. Okay, so see here two-dimensional method. That is what the in one in for the first time it is moved in this direction, and for the next time that is moved in horizontal direction. Hence there is a two-dimension. Okay, so multiple development, in multiple development you can use first time like this. Okay, again if you want you can move like on the same direction, for same direction multiple development. Okay, and if you want then you can also keep it in the horizontal direction. Okay, so that is what the multiple development, that depends. The target is to only the separate the all possible components which are present in the sample. Okay, so detection and qualitative analysis, detection and qualitative analysis. Okay, so here the some of the physical methods are there, some are the chemical method. Okay, you can use for the enzymatic and biological detection method. Okay, so here only qualitative analysis is possible with the technique, and quantitative analysis is not possible by this technique. Okay, like TLC, the technique can be used for the separation, identification, characterization of the component present. Okay, as most of the component are colorless, the developing methods will have to be used for the detection purpose. Okay, so different methods are employed to develop the color for the spot and hence to detect them. Okay, so the method of detection depends on the nature of component present in the sample. Okay, so in the physical method you can study the absorbance. Okay, then you can study the fluorescence. When we are going to study after separation of the component, okay, from the sample. Okay, so wavelength use maybe 250 to 260 nanometer. Okay, and you can see the fluorescent light which will you observe on the paper. Okay, and that will indicate that the components are separated or not on the paper. Okay, and that is very easily observable. Okay, for that purpose we are going to use the high pressure mercury vapor lamp, high pressure mercury vapor lamp. Okay, next is the chemical method. In the chemical method, what happens there, if metal ions are there, then chelating agents or complexing agents are need to be used. Okay, if carbohydrates are there, in that case we need to use KMNO4. Okay, and different reagent we can use. For the study of amino acid we need to use ninhydrin. Okay, in this way, depending upon the properties of the sample component, we can use different chemical method for the analysis purpose. What happens in the chemical method, whatever components get separated on the paper, that reacts with the reagent. Okay, and then they will show you the color, or sometimes fluorescence, or the absorbance, like this. Okay, so these things happen, and that is carried out only to see the separation or the types of component present in the sample. Okay, so enzymatic and biological detection method. So substrates are detected by the use of enzymes. In some cases, the incubation of the paper may become necessary for the identification purpose. Okay, so in the quantitative analysis, so the method as such cannot provide much information regarding the quantitative or the quantity of components present in the sample. Okay, but and even the technique is not much accurate. Okay, so this is what the information regarding paper chromatography. So where we can use the paper chromatography, is this technique really applicable in our day-to-day life, or is it having much importance in our day-to-day life? Yes, it is having. So it can be used for the analysis of inorganic, organic, and biochemical substances. Then it is used for the separation of metal ions. Okay, it is used to separate the groups which are having similar chemical character. Okay, it is used to separate the isomers. Okay, like optical, geometrical, and substitution isomers can also be studied with the help of this technique. Okay, the natural product analysis can also be carried out by using the paper chromatographic technique. Purity of sample can also be tested by this technique. Okay, pure sample will produce only one spot. On the other hand, if sample is impure, if other entity is present in that sample, then you may get one or more than one spot over there. Okay, and that only indicates that the sample which we are going to use for a certain purpose is having a kind of impurity in it. Okay, so the technique is extensively used in biochemistry, then separation of biomolecules, amino acids. Okay, then related compound. It is also used in the field of food analysis. Okay, it is also used in the field of food analysis. So these are the what the comparison. These are the what some distinguishing point between thin layer chromatography and paper chromatographic technique. So both the techniques are planar, as I told you. Okay, so here separation phenomena may be adsorption or partition. Here is only partition, as stationary phase is only liquid in case of paper chromatography. Here stationary phase used are the silica, alumina, or any other adsorbent, while here different type of papers are used. So liquid phase or mobile phase is organic solvent. Here is mobile phase, maybe organic solvent or aqueous or the water. Okay, then the parameter is the retardation factor in both the cases, which we are using for the analysis purpose. So here ascending, multiple, and two-dimensional technique use. All of these and plus some more techniques are used. Okay, physical and chemical methods are used for detection. Here is also same. Okay, here the organic, natural product, kinetic studies, and qualitative studies can also be carried out. So here in this case, organic, inorganic, biochemical, and qualitative studies carried out. So this technique is selectivity good. Here in the paper chromatography also selectivity is quite good. Okay, so after that there is a thin layer chromatography. Remember, all the things are similar in paper chromatography and thin layer chromatography, except in paper chromatography, mobile phase, stationary phase is the liquid, and in thin layer chromatography, mobile phase may be solid, may be liquid. Okay, in paper chromatography, only paper is used. In thin layer chromatography, there is a use of glass or aluminum or some plastic or metal plates. Okay, for the support purpose. While the whatever separation, whatever developments are there, that are similar in both the cases. Okay, so the very similarity in between these two techniques, I think once you understand the paper chromatographic technique, then thin layer chromatographic is very easy to learn. Okay, so here I will stop in this lecture and I will just continue thin layer chromatography in the next lecture, so that there would be the no confusion between two techniques. Okay, intentionally I'm just finishing my previous lecture over here. Okay.